In today's class, we will discuss something called flammability diagram or flammability chart. Flammability chart is a very powerful tool that's going to be used, or you're going to see it in this chapter and the next chapter. And it's used intensively in the industry, and it has so many applications because it's a very powerful tool where you can determine or find where's the zone or where's the area where you have a combination, or where the recipe will give you a fire, or the combination or the concentration profile for the three material will give you what we call a recipe for a fire. So the flammability diagram, as you can see, it has three elements. It's triangle, okay, that has three corner and three elements. So on, for example, on this axis, I'm going to explain it now in a bit in details. So on this axis you have the fuel, where the concentration of fuel here is 0 and the concentration of fuel at this point is 100. Okay, on this element here, I'm going to use another color. You will see what we call the oxygen, and the oxygen concentration starts at this point where you have 0 concentration of oxygen, and it will reach the point where it has the 100% of oxygen. And now we go to the third element, which is the nitrogen. On the horizontal line, you have 0% of nitrogen at this point, and you have 100% of nitrogen at this point. So now let's look at the three corners. At this corner, for example, okay, at this corner, you will have two concentrations. The concentration of fuel to be equal to 100%, and as a result, the concentration of oxygen and concentration of nitrogen will be equal to 0 and 0. If you go to this point, at this point you have the concentration of fuel equal to 0 and the concentration of nitrogen equal to 100, which means that the concentration of oxygen equal to 0 as well. Okay, and let's look at the third point, or the third corner. Let me just choose front color. At this point, the concentration of the oxygen equal to 100% and the concentration of nitrogen equal to 0%. Okay, so now if I want to use this thing, let me call it oxygen, fuel, and nitrogen. If I want to go at this point, the oxygen concentration at this point is equal to 0, the fuel concentration is equal to 0, the nitrogen concentration is equal to 100. Okay, let's go at this point now. This point, the concentration equal of oxygen equal 100, the concentration of nitrogen fuel equals 0, and the concentration of nitrogen equals 0 as well. Let's go to this point. The concentration of oxygen here is equal to 0, concentration of fuel equal to 100, and the concentration of nitrogen equal to 0. So I can represent the combination or the concentration of each of all of these three elements in one point. For example, each point has three different concentrations: one concentration for fuel, one concentration for oxygen, and one concentration for nitrogen. The bottom line is that the combination or the summation of all these concentrations must be equal to 100% or 1. Okay, now if you still remember, because you have seen this triangle for sure in thermodynamic and material science, if you still remember that normally if I choose any point as a rule of thumb, let's say that I choose this point. I'm gonna put it now in let me put it in green. So I'm gonna choose this point on the top corner of the triangle. So this point at the top corner of the triangle is opposite to the line that represents the nitrogen, and as a result, and as a rule of thumb always, the concentration of nitrogen at this point will be equal to 0 always. Okay, let's now look at this point, which is, I'm gonna take it into red, as red color. So this red color, this point, opposite to this corner is the fuel, As a result, the concentration of fuel at this point will be equal to 0. Now let's look at the third point, which is I'm going to take in purple, this point. Okay, this point has, or this corner has, the opposite line of oxygen. This means that at this point the concentration of oxygen equal to 0. And you have also to keep in mind that any point inside the triangle, let's say here, let's say here, let's say here, or let's say here as point A that I'm pointing, every point inside the triangle has 3 readings. 1 reading for fuel, 1 reading for oxygen, 1 reading for nitrogen. Now, why did we choose oxygen and nitrogen? Because this is the composition of air, and that's normally what starts the fire. That's why we choose air, and we choose air, which is oxygen and nitrogen, as a mixture of fuel. So now let's try to read the point A, the coordination at point A. Let's look at point A. This is point A. So if I'm going to read the nitrogen concentration, so this is my nitrogen concentration. So I will go, and I'm going to just use different color. I'm going to use blue one. Okay. So let's say that I'm going to look at the nitrogen concentration at point A. So if I go this way, parallel to this line, I will get the nitrogen to be equal to 10% almost. So the concentration of nitrogen at point A will be equal to 10%. Now let's look at the concentration of oxygen. So this is the oxygen line. This is my oxygen line. Okay? And at point A, I can draw this line at this direction, and to get a concentration of oxygen equal to 20%. So even if I want to stop at this point, it's by default 20% of oxygen, 10% of nitrogen. This means that 70% is fuel. If I forget to do that, you can simply go to the fuel. Fuel is coming from 0 to 100. And how much is this concentration here, which is the intersection of this? I will take a horizontal line from point A to the element or the line that represents the fuel, and this is equivalent to the 70%. So this is how you read any point. This is how you read any point inside the triangle. Let's say that we are talking about this point. Okay, let's say that I'm gonna call this point as point P. Try. Now let's look for nitrogen. How much is the nitrogen? 20%. So the nitrogen will be 20% at point B. Let's look at the concentration of fuel. Fuel will be horizontally this way. This means that it's around 50%. Let's look at the oxygen. How much is the oxygen for this point? I will go this way, sorry, which is equal to 30%. So this is how you read any point inside the triangle. But any point on the element itself, any point, and at this point, let me just take it in, let me choose the green color. Now we learn how to read any point on the triangle. Now let's learn how to read any point on the element itself. Let's say that I'm going to choose this point. I have assigned this point, for example. Okay, so I have assigned this point at the horizontal axis, which represent element 1, which represents the nitrogen concentration. So any point on this, or here, or here, any point in any of the 3 elements of the triangle will give you only 2 readings, and the third reading will be equal to 0. So let's come to this point. This point. So this point is, I'm reading at the nitrogen. So let me just stick to the same value. So nitrogen is 60%. Okay. So now this element of nitrogen is opposite to this point. So I'm gonna go. This element is opposite to this point, where this point has 100% of fuel. So as a result, there will be no chance at this point here to have a fuel. This means that my fuel composition will be equal to 0. And as a result, the composition, the third composition of oxygen will be, if I draw this line, it will be 40%. Okay? Cool. Now let's look at another point. Let's look at this one. Let's say that I'm going to choose another color. Let's say that I'm going to look at this point here, at this element. This means that at this point I have again 3 elements: oxygen, fuel, nitrogen. But which one will be equal to 0? Let's look now. First of all, this is the fuel element. This is the line of the fuel. This means that I will have a specific concentration of fuel. This means that the specific concentration of fuel will be equal to 0. Okay? And I look at this line. This is the fuel line. Okay? Which is opposite to which point? Which is opposite to this point. And at this point I have 100% concentration of oxygen. This means that at this point specifically there will be no chance that I have oxygen. Then the oxygen concentration will be equal to 0. This means that I have another 50%, or I can simply draw a line parallel to this line here, which will read 50% again of nitrogen. Let's look at this point now. Let me just choose another color. Let me choose the black color. So now let's look at this point. Again, I have 3 composition: oxygen, fuel, and nitrogen. So at this point I'm looking at the oxygen line. This means that I have the oxygen concentration, which is going to be straightforward equal to 60%. So I have 60% of oxygen. But now which component will be equal to 0? I will look. This line, or this element of the oxygen, is opposite to this line, or to this point, where this point has 100% nitrogen composition, which means that the nitrogen composition will be definitely equal to 0. And as a result I will have 40% of fuel, or I can simply say that this is equivalent at this point. This is my reading of the 40% of fuel. So now we have learned from this slide, we have learned how to read any point inside the triangle that has 3 values for oxygen, nitrogen, and fuel, and any point on the element itself will have 2 reading, and we know how to get the third one as equal to 0, which is the point which is opposite, where the maximum concentration, or the 100% concentration, is opposite to that line. So if I'm looking at the fuel line is opposite to this corner, where this corner has the oxygen concentration equal to 100%. Similar thing, if I'm looking at the nitrogen line will be opposite to the point at the top of the top corner of the triangle, which has 100% of fuel, which means that any point at the nitrogen line will have a fuel concentration equal to 0. And now we look at the third point, or the third element, which is the fuel line. Fuel line means that fuel line is opposite, or no, oxygen now. Now the oxygen line is opposite to the point where I have 100% of nitrogen, which means that if I'm looking at the oxygen line, there will be no chance to have any nitrogen concentration. So therefore nitrogen concentration will be always equal to 0 at the element. So at the 3 elements you will have always 2 readings for 2 concentration, and the third one will be equal to 0. Inside the triangle you will have what we call the 3 readings for oxygen, nitrogen, and fuel. And you will see also here, it's not clear, but I'm going to explain it in the next slide. There are 2 lines called, the first one is called the air line, which is this one, where air line represent the maximum and the minimum concentration of air composition that can be, where you can see that at this point you have the 21% of oxygen and 79% at this point I'm talking about. I have the maximum composition, or the maximum concentration that I have for nitrogen is 79%, 21% of air. So this is one composition. And the third, or the other composition, is when I have no air at all. So I go from the maximum concentration of air at this point, which is 79%, nitrogen 21%, oxygen, to the point where I have no air at all at this point, which is only I have fuel, 100% fuel. So this is what we call the air line. And we have something also called stoichiometric line, and we're going to learn how to see or how to draw the stoichiometric line, and we'll learn how to define or locate the upper flammability limit and the lower flammability limit of that component in pure oxygen. We're going to see this in the next few slides. As I mentioned earlier, like flammability diagram or flow flammability chart is very powerful tool. It's very useful when you are dealing with mixture of flammable material, when you are dealing, for example, with hydrogen, methane, ethane, propane, and a mixture of air, which you have nitrogen and oxygen as well. And it's very required to prevent fire or the combination or to prevent the formation of flammable mixture as well. A problem associated with this diagram that it's based on experimental data, and you don't have experimental data for all the chemicals, but at the same time it's very powerful tool to determine and prevent flammability zone as well. And it depends on the chemical species and the temperature and pressure as well. That's why this is very important to say that it depends on the chemical species, because we'll see toward the end of this section that it doesn't all has the same shape. All of them will have all the time that's the fire zone or flammability chart. But for example, if I'm dealing with H2, you will get completely different combination or completely different shape for the flammability chart than when I'm dealing with methane or ethane or propane or benzene or toluene, because the border of that area is what we call the upper and lower flammability limit. And the upper and lower flammability limit is a function of the material. It depends on the material. Therefore, the whole flammability chart will be 100% dependent on the material itself that you are choosing. Flammability diagram, we talked about how we distinguish or how can we allocate a percentage or a combination of material. Let's look at this example where you will learn how to read the combination. If you are looking, just let me use a different color. If you are looking for nitrogen composition, then I'm going this way. If I'm reading, for example, the oxygen concentration, then I'm going this way. If I'm going for fuel composition, then I'm going horizontally this way to measure how much is the exact concentration of fuel, how much is the exact concentration of oxygen, how much is the exact concentration of nitrogen. So we have seen this exercise in the slide before, so please try to do certain points if you want. And now we're going to talk about what we call the airline, where airline give you all the combination that's possible of fuel plus air. So this is like the airline give you all the possible combination for fuel and air together. So you might have one scenario where you have 100% of fuel, which is this point, which means that you have 100% of fuel and 0% of air in general, which is oxygen and nitrogen. And the other scenario, the other extreme scenario, is when you have the classical air only, which is 79% nitrogen and 21% oxygen, and the fuel equal to 0. So the airline, which is normally drawing in this, and it's always fixed airline, give you all the possible combination that can be composed upon the mixture of fuel and air. You can get only pure air where you have only oxygen and nitrogen, and you can get only pure fuel where you have only fuel, there is no air in that diagram or in that point. This is how you normally draw the airline. It normally goes from the point when you have 0 oxygen, 21% nitrogen, 79% oxygen, which was on this point, if you still remember the triangle. So this is this point, to the point where you have here, which represent the composition when you have 100% fuel, 0% oxygen, and 0% nitrogen, and this is normally what we call the airline. Okay, you can also get it through what we call another equation, which is equivalent, or fuel, which is equivalent to minus 100 divided by 79 nitrogen plus 100. But normally, as a rule of thumb, you can take it as this extension between these 2 points. as simple equation. You can just take it as this, where the fuel concentration at any point can be represented by this equation. The second line that we're going to discuss is what we call the stoichiometric line. And normally the stoichiometric line, if you are taking this triangle in this shape where nitrogen is in the horizontal line and this is the oxygen, normally the stoichiometric line will be always extended from the point where you have 100% of nitrogen and 0% of oxygen and 0% of fuel to a point on the oxygen line. But how can I specify this point? By using this equation, where this equation equal to Z divided by 1 plus Z multiplied by 100%. And if you still remember that Z is the stoichiometric coefficient of oxygen. So if I'm talking about methane, this means that the stoichiometric coefficient, or Z, will be equal to 2, then 2 divided by 3 multiplied by 100%. So this point will be equal to 67% of oxygen. So now we learn two things. We learn how to draw the airline, and we know how to learn how to draw the stoichiometric line. And as we mentioned earlier, normally stoichiometric line will be extended between 2 points. The first point is when you have 0 nitrogen and specific amount of oxygen, which is 100 Z divided by 1 plus Z, and specific concentration of fuel, if you know the Z, which is, where is that? This is the triangle, this is nitrogen, this is oxygen, this is fuel, and I'm talking about the point where it's here. So this is this point where you have 0% of nitrogen, 100 Z divided by 1 plus Z oxygen, and fuel 100 divided by 1 plus Z, to a point, I'm going to draw it on another line, to a point where you have 0% of fuel, 0% of oxygen, and 100% of nitrogen. This is what we call the stoichiometric line. Okay? And the equation for this line as well, or the fuel composition for this line, will be always found through this equation, which is fuel equal to, or the fuel composition equal to 100 minus the nitrogen composition divided by 1 plus Z at any point. So now we learn how to establish the stoichiometric line and the air line for the flammability chart, or the flammability diagram. And now we come to the last component, which is the LOC line, or limiting oxygen concentration line. And normally after you specify the flammability zone, where this is going to represent what we call UFL, and as I mentioned, UFL will be given to you in oxygen, and this is going to give you what we call the LFL for this material in pure oxygen. And once you draw the area, or the flammability zone, okay, you can approximate the line over what we call the LOC, where LOC barely it goes from this point to a point on the nitrogen axis where it barely touch the corner. Oh, sorry, it's not clear. Where it barely touch the corner of the flammability zone. So this is what we call the LOC lines. So the LOC lines will be drawn at the end, where after you specify where is the border or the corner of the flammability zone. And if I'm dealing with this means that, if I want to understand this chart, this means that any combination here will be flammable or will start a fire. So the fire will start at any combination here. If I choose any concentration in this zone, the fire will start. Here you are green, safe. Here as well you are green, safe. Here as well you are green and safe. But anything in red or inside that specific zone, the fire will start if you have this composition or this combination.